we'll wait one more minute in case anybody's running late, and then let me actually this. Perfect. Okay. So while we're waiting for anybody to get started, keep an eye on your due dates. I know I have to grade assignment number 1 still. I'll try to get to that today. That one was due, I think, last week. Yeah. And then we have assignment number 2. Any questions on assignment number 2?
No.
I think that should be pretty straightforward for most people. And then assignment number 3, which you've probably seen some variant of this if you took COP2030 with me. But like I said, some of these problems I like to stick to because I know they're understandable. And it's like, why change it into a problem that may not work? So I reuse some of the basic problem, but it kind of gives you a stable problem that you know how to solve, or a very easy problem if it's the first class you've taken with me, and then you can concentrate on the mechanics of solving that problem with Python, rather than like a really hard problem. You're trying to solve the problem and program it at the same time. We'll go over it, but just to keep an eye on things, it's going to be due in 1 week. And then after this assignment, I think I'm going to switch to 2-week due dates. They kind of cluster up at the beginning because they tend to be easier, and especially because this is a supposed to be like a second programming course for most people, second or third. I'm sort of assuming that the stuff in the beginning is, it's just like learning things that you already know in a new programming language. Okay, so keep an eye on that, but I'll explain that as we go along. No, nothing's dropping. Okay, I guess we'll get right into it if there's no questions from anybody. Imagine the pace of the course is okay for everybody. Haven't had any complaints, so we're not going too fast for anybody.
No.
Perfect. Okay. So let's open up a new REPL here. So let's do I think we already did a tip calculator last week.
We did.
Okay. I know. Let's do one that's sort of related to your assignment, just as a quick review. So assignment number 2. Actually, oh no, you get the simple version, right? You don't have to go both directions.
Yeah.
Okay.
This part has to tell it.
Okay. So let's pretend, even though on your assignment you don't have to go both directions, let's do something menu-based, and we'll tackle a couple things along the way. So in this program, we want to go liters to gallons, or gallons to liters. So if this is a menu-based program, we have to ask the user what they want to do, and they don't really have much as far as the choices go. So we do print, press 1 to go liters to gallons, press 2 for gallons to liters. And then their choice is going to be equal to input, enter choice. And we don't want to write too much code without testing things. It's not going to do anything, but at least it compiled. So let's look this up real quick. So it's going to be 1 liter to gallon. So they've entered in choice. Now, if I want to know I mean, you should already know this, but just to kind of remind everybody that whatever I enter in, even though I've entered in a number, let's say I wanted to go liters to gallons, number 1, we can see that it's actually a string. Now, last time I think we left it as is. Turns out it doesn't really matter in this case because we're not going to be doing any math on it. But let's say, for example, we wanted to convert it to a number. I mean, there may be you may want to do something if you've got like grouping menu choices together. Then maybe you want to do some math and some comparisons. So there might be an instance where you may want to convert it to a number. So the two types of numbers that we're working with are either integers, which are positive and negative whole numbers, and floats. So in this case, if we're going to convert it to a number, do you think it's better as an integer or as a float? Integer. And what's just the intuition why you think it fits better into an integer?
Whole numbers, you only have whole number selection.
Yeah, exactly. Somebody wouldn't enter in a choice 1.2 because all we've given in the choices are the whole number 1 and the whole number 2. So we'll say choice is equal to, and then there's a function called int, and it'll take our choice and turn it into an integer. Now, just to double check, we could say print the type of that variable choice, and it'll no longer be str, it should be int. Now, immediately after this, we're going to do an example that's going to seem kind of strange. But there's actually another reason that we don't use float, because remember, the number 1.0 and 2.0 are actually technically floats. So I guess I didn't really have to use an int, but at the same time I did have to use an int, and it'll make sense after this. Okay. And so we say if choice is equal to the number 1, because this is an integer, we're going to do something. Now, just to let you know is that if we want to put a placeholder, we don't want to put any code yet. What we have to use this special keyword called pass. I don't want to put code just yet. A lot of times I like to put in the skeleton first. So if choice is equal to 1, do something. And then remember that we could write an else, but that's not really ideal because we want to specifically say, okay, if choice is 1, if choice is 2, and so on. So if choice is equal to 1, elif choice is equal to 2. Remember, we don't use else if, we use this combined keyword elif. And then in all other cases, we know that it's just going to be invalid input, so we'll just say print invalid input. And let's just test that. Let's just put in, and only thing that really work is like if I put in choice 4, it should say invalid input. So we've done these conversions a bunch of times. So if choice is equal to 1, that means that they're going to provide liters, right? We're converting liters to gallons, so they're going to provide liters. So we say liters is equal to input, enter liters. And that's as a string, so we want to convert that to a float because somebody could theoretically want to convert 1.5 liters. So we say liters is equal to float liters. And then we actually do the conversion. So they want miles, so we say miles, gallons. I'm so used to doing the other examples. so they want gallons, and then we're going to say that gallons is equal to liters times this magic number. We don't really care why this number exists. We're just doing simple conversion. And then we would print. And remember our format strings, we use F. Gallons is gallons. Yes.
So currently, so if I have gallons equals liters times blah, that was just lit up red.
What's that on yours?
Yeah. Gallons equals liters.
Hover over it. Usually they'll say why is it between gallons and gallons. Move your cursor. Liters. Oh, and then you have to have the 2 right. Yeah.
And then lit up red gallons.
And we'll fly through this because we've done these a million times at this point. So we'll say, okay, and this one, that if they press 2, that means they want gallons to liters. So we'll say gallons is equal to input, enter gallons. And they want liters. So we say liters is equal to gallons times 3.78. Did we do this right? So 1 gallon is 3.78 liters. Right, so if they enter in 1 liter, it's going to give us 0.264. If they enter in 1 gallon, it's going to give us 3.78. Perfect. Now, one very quick last thing that we could do is we could make this like a program that runs forever until they press some key to quit. Now, I would say leave your example as is. I'll modify this, but don't change your example because we're not really at that point in the course yet, but it's just good to preview some of these things. So what we could do is, unfortunately, because I wanted to give the example using int, any key that they type in, it's going to have to be a number. So normally what we could do is something like this, where we'd say print Q to quit, something like that. But maybe instead we could say 9 to quit or 0 to quit. And then what we could do is we could wrap the whole thing in, do you remember while loops? So while something is true, it keeps on going. Now don't type this because it's very fragile. I don't want anybody to accidentally break their project. So just, you can leave what you had We can say while, and there's a special keyword called true. Remember, everything when you do a comparison has to either be true or false. While true, is that ever going to stop? No, it's what we call an infinite loop. It'll keep on running forever, which probably seems useless. And so what I'm going to do is remember that for each block, each time we have this colon, we want to indent one level. So what I can actually do is I can just take this whole thing, and most editors let you do this, where you just highlight it and you hit tab, and notice that it went in one level. But we know that I must be able to quit somehow, because I had 9. So we'll know that, okay, well, if choice is equal to 9, how do we quit? Well, there's this special keyword called break, which can let us break out of an infinite loop, or actually any loop. In this case, it's infinite, but if you want to break out early from a loop. So now if I wanted to, I could run this program. The reason I'm saying it's fragile is because if you mess up this piece of code, it's going to want to run forever, and I don't know if it'll break your REPL or not. That's why I'm a little bit hesitant to have everybody type that. So you could do a conversion to, and then 1.5, and then it gives us the answer. Maybe you could add some nice text art and separate it and make things nice, tab things and whatever. But now we get our screen again, and then now if I enter in 9, it ends the program. And maybe you want to write something nice like just so you have some cue that the program actually ended, but you get the idea. Okay, any questions? And don't forget, I post these code examples, and this is recorded, so if for whatever reason you're not able to run this example, you can grab the code after class or watch the lecture again. So let's dive into something interesting. It's kind of the low-level technical details of a language. So I just told you that this kind of has to be an int. If it's not going to be a string, it has to be an int. We can't use a float here. So what are the basic comparison operators of when we're using like if statements and any sort of conditional statements? Well, I can have the greater than, less than, greater than equal to, less than or equal to. And that makes sense when I'm comparing two floats. Like a float can be greater than another float, less than another float. This double equals right here, this is kind of special. This is called the equality operator, and it checks to see that both things in the left and right hand side are equal, which may seem extremely straightforward. Let me walk you through an example on why the comparisons are straightforward, but the double equals, that equality operator, it's not necessarily straightforward. Okay, so I'm just going to run through kind of a dummy example. It's not going to be really anything interesting. I'm going to say that A is equal to 0.1, B is equal to 0.2, and the result is going to be A plus B. And what I want to check for is, okay, if result is equal to 0.3, print equal, else print not equal. Very, very simple program. Now on planet Earth, what is 0.1 plus 0.2? What should be the result? 0.3. So it should print equal. A little strange, right? And I wouldn't expect anybody to know this ahead of time. So you might think, that's weird. So I might want to print, okay, well, What is the actual value of result? Does everyone see that?
Yeah.
I always tell people at the beginning of class, and it's like this awkward speech because it's kind of a complicated topic, but I want to bring it up. I say, don't ever use floats or doubles for any sort of monetary anything. Because in the accounting world, I doubt there's any accounting students in here, but in the accounting world, is this okay? If I had somebody owed me a penny and or 10 cents, and another person owed me 20 cents,
No.
reports at the end of the day, no, they won't. However, if I'm running a physics simulation on the very first computers, let's say, for example, I'm trying to send a weather satellite up in the air, this is probably actually acceptable. Because many times in physics, they don't actually, they tend to work in decimal numbers. They don't actually, they just need a certain level of precision. They don't care if beyond that precision, it's not quite accurate. It's not like a symbolic math class like algebra where you actually get an exact answer. These first programming languages that they created, which influenced pretty much every language afterward, didn't have guarantees. They were more concerned about the physics world than they were about the accounting world. And in the physics world, they came up with something called a floating point number, which is a very, very clever way of compactly representing decimal numbers. But the problem is that if you try to convert it to a base 10 number, it wasn't always accurate. So that might not make sense. But for example, if I do 10 divided by 3, I can represent that very easily, right? 10 divided by 3. But if I try to actually represent it as a decimal number, what would it be? It would, essentially we'd end up with a repeating number forever, which you can't really represent. Same thing happens here, is that they came up with a very clever way of representing numbers base 2 with a floating decimal point. But as people, what we want is we want the number represented as base 10. And so what often happens is behind the scenes on the CPU, it'll do these calculations, and then it'll do its best to try to come up with a representation for us as people, as humans. So that's why we end up in weird situations that we can never guarantee equality. Does everyone see why greater than and less than is probably okay to use? Yeah. It's because even though this has less precision, if I were to say, is 3 greater than 1? Even though this is off a little bit, or 0.3 is greater than 0.1, even though this is, it's like off just a little bit, that still holds. So it's fine for greater than and less than comparisons. It's when you need an exactly equal number that it causes problems. And to be honest, every once in a while, especially in Python, I catch myself accidentally doing this because most times it works. This was a very manufactured example to find a time it doesn't work. Okay. Now, if you do want to write a program that deals with money, how do you do that? Most of the time, what I would suggest is just the easiest way is just always deal with pennies and use an integer because you don't run into this issue.
Oh, so it's like 1 penny plus 2 penny plus 3 penny, so you never get into the decimal.
Yeah, exactly. You don't generally have to. And then if you need to divide numbers, you just have to be kind of aware that certain things might be off. But your actual storage of things, you would store as pennies and integers. Now, in other languages like Java and C#, they actually do have a native type called decimal that does guarantee that this will never happen. It just is much slower, so people don't use it very often. Like if you ever taken a C# or Java class, my guess is you probably use float and double instead of this. In Java, it's called big decimal. It's because it's like most of the time this behavior is okay. You just have to be aware of it.
We just whenever data types didn't even come out.
Yeah, it's very rare. It's really for if you're doing accounting work and dealing with money that you deal with the decimal type. Okay, any questions about this? So the takeaway from this is that if you've got a float, don't use the double equals because you might end up with strange behavior. And that's why in this previous example, remember I said we could create this as an int or a float. Does everyone see now why I chose the integer? one was the obvious choice that you can't really enter in 1.5, but the other is that we may end up with strange behavior, so we just don't want to get ever, just as a blanket rule, don't use double equals the equality operator if either one of these is a float. Okay. So let's keep going here. Let's do an example related to the homework. Let's just get some more practice with if statements. So pay attention to this example. This one's going to be directly related to your homework, and then we're going to do some stuff with lists and maybe even for loops, just kind of as a preview. But this problem right here, this is going to be the main thing for your homework. That's good, perfect. So let's have a program that if you've ever bought anything in bulk, let's say like dirt or gravel or any sort of item in bulk, you know the basic idea is that if you buy a small amount, the per pound price will be higher versus if I buy a bunch, usually since they'll give me like a bulk discount, the per pound price of the item will be less. So let's do something like that. So we're going to basically say that, and I'm going to write some of this vague. I always do this on purpose vague because I want you to get like some real world experience. So we're purchasing gravel, and the pricing table is going to be from 0 to 10 pounds, or whatever the units are, kilograms, doesn't really matter too much. It's going to be $2 per unit, per pound. Put the word is. If we're purchasing 10 to 50, we'll say it's $1.50. And 50 to 100 is $1.25. Yeah. I try not to reuse examples, but some of these over the years I kind of stumbled across, and I kind of see the light bulb go off in everybody's head, so I try to reuse the stuff that kind of makes the light bulb go off for everybody. What's that?
This example and the car example was one of my favorites.
Oh yeah, because it explains a lot. Okay, so if I'm, let's say I'm writing some sort of cash register type program, and we're writing the code that actually calculates. So they call in, they say, I want to order 75 pounds of gravel. We need a program that gives them the exact price. So the very first thing we have to do is the boring stuff that we always do. So we say that we want to know the weight. Let's say, okay, enter the weight. And right now, I really don't care about the actual units, whether it's kilograms or pounds or whatever. And then because somebody might want to buy 5.5 pounds of this, we want to convert that to a float. By the way, remember previously I said don't use floats for money? I'm going to break that rule. Because the real way to do it using integers, it can be a little bit complex. Not super, but for intro classes like this, I'm going to wave my hands and say this is the time it's okay. But just remember, once you get in the real world, when you're dealing with real money, things change really quick. Okay, so at this point we have the weight, and it should be obvious this is an if statement. Now, looking at this rate table, I can start to implement it. I can say, okay, well, if the weight is, I don't really care about greater than or equal to 0, because if somebody's purchasing 0 units of something, that's kind of pointless. So we'll just say greater than 0. And then if I want to check to see if a number is between two numbers, what I can do is, okay, and, remember this and keyword checks to see the two things are true. Weight is less than or equal to 10. We'll say pass. We'll put in the logic later. By the way, the reason you have to do this is because remember, this is like a white space dependent language. So if I don't have this and there's no placeholder there, yeah, it causes all kinds of problems. So this is just like a placeholder that it doesn't do any operations. It just kind of sits there. Okay, that's good. So we've got something here. If the weight. Well, the way I've written this rate table, it's not super clear. In the real world, this is how you get stuff from customers. It's very common to get something like this, and then for that small little time where they get 10 exactly, it's usually such a rare case that they might, might be up to the cashier. Maybe they've just internally decided to do something. But it's very common that when you're writing software for people, in their head, they think that the problem is a very clearly defined problem. And when you actually convert it to computer code, it's very often not the case. And that's actually a skill in itself. Writing software is actually really, really easy. Taking a problem that somebody's given you and writing it to always work correctly in a software and in a programming languages, that's actually the much more difficult part. And that's kind of just a skill you get over the years. And so here's the problem that we end up with. If I were to write, okay, else if weight is greater than 10, but this is a little bit, or let's say greater than or equal to 10. We have a little bit of a problem with this because really we've defined 10 twice. We've got a small overlap. Now, which one's going to win? Because it's an if, else if structure, this one, if we entered in 10 exactly, this one would be the one that wins. But we want to be clear, even though it's not necessarily a bug, we always want to have very clear code. So what I'm going to do here is I'm just going to make the executive decision that, okay, well, we don't want to include 10. So here we're saying up to and including 10. And that means from here, starting just after 10. Does everyone remember like number lines from algebra where you do the hole that you'd fill in or you'd not fill in? This is kind of the same thing here. So we'd fill in 10, and then we'd have the little gap here. We would say greater than 10. Okay. And then from here, it's just very formulaic. We would say and weight, and we'll keep the structure of it less than 50, less than or equal to 50. If the weight is greater than, not including 50 because we already included that there, and weight is less than or equal to 100. And then finally, we just print invalid weight. So that means that maybe after 100 pounds, you'd have to get it from a larger supplier. We can be very generic. You could even add another else if it's greater than specifically 100 pounds, that you could give them like a nicer message that says, sorry, we're not equipped to handle orders that large. And then something specifically for 0 and negative that would say just that's an invalid input. But we'll keep it generic for now, so we're not writing something too long. Okay, so we're kind of getting there. Now we actually have to fill in this past stuff. So let's do this. Let's say that the price is going to start off at 0. And to calculate this, what we do is essentially we say that the price is going to equal the weight times the value in the rate table. So in this case, it's going to be 2. And just so it sort of looks like money, we can say 2.00, even though it doesn't actually care. Here it was price is equal to the weight times, I think I said $1.50. And then rather than putting 3 different print statements in here, what we could do is we could just have one final print statement at the end. We could say print price is price. So let's spot check this. So if I do 5 pounds, let's say, that should be 5 times 2, so the price should be 10. You always want to check the edge cases. So let's say, for example, if I entered in 50 exactly, it should give me, I think, 75. So that looks okay, and you'd be very complete about this and go through. But what if I enter in an invalid weight? I get price is 0. Because we've initialized the price to some sort of default amount, what we could do is we could say, okay, only print this if price is greater than 0, which means we actually calculated some sort of price. Only print it if we have a valid price. Okay, and I always like to use this example because in the real world, there's two things that you have to always consider. So there are two things I want to show you. Is that one is that obviously if I want to find a number that's between two numbers, actually within Python there's actually a special syntax. I don't ever see anybody use it. I think there's like a between keyword or something like that. Or something like that. I never use it. What I always do is I say this condition, remember which has to evaluate to true or false, and this condition, if those are both true, remember that's how ands work, if both of these things are true, then we do that. The one thing that we want to avoid is that. This is how we would read it in English. We would say if weight is greater than 0 and less than or equal to 10. It's great that we read it in English like that, but you can't really convert that into code. You have to be very specific. You have to say if weight is greater than 0 and weight is less than or equal to 10. And then the other thing I always like to use this for is, again, in the real world, it's very common to get things that at first glance seem like a well-structured program or problem that you could convert into a program, and then in practice, it very quickly is not the case anymore. Okay. Any questions about this? So this is going to serve as the basis of your homework assignment. Now you're going to, this one you're going to calculate shipping costs. And it's similar, so you're going to do slow, medium, and fast. And I would suggest doing 1, 2, 3, because otherwise you have to get into, like somebody might misspell the word medium. How are you going to catch that? You have to worry about capital and lowercase. There's all kinds of issues. I would suggest when you have a menu system, do 1, 2, 3. So the first part is very similar. You're going to calculate based on weight. So between 0 and 1, it's a price. 1 and 3, 3 and 10. It's almost exactly like this problem, except for I'm just changing some numbers. But then there's a second part that if you've ever shipped anything, you know that you can get like ground shipping, which may take 2 weeks. Something a little bit faster, like second day or overnight, and you're going to pay based on that. Now, how do you do that? So if you're going to be using the slow shipping method, just multiply it by 1.0. Now, this always throws people off. Why do this? Actually, let's come back to it. So then if it's medium, it's going to be 10% more. So you multiply that by 1.1. 50% more is 1.5. I like to keep symmetry and placeholders in my programs, even if they don't do anything, if it makes the program more clear. Because what may happen one day is that, typically actually you wouldn't hard code these inside of your program. They would almost always be retrieved from a text file or database or something like that. So you have that. But the other reason is that what if you have a 2-day sale? it's much easier just to change one single number than it is to add additional logic to your program. So if all of a sudden you have 10% off of the slow shipping, you just, rather than multiplying it by 1, you'd multiply it by 0.9, and all you'd have to do is change a single number. So if it makes your code more clear, it's generally a good idea to have placeholders. So it's going to be a two-part program. The first part, you're going to calculate the base price. And then the second part, you say, okay, well, now I know the base price based on the weight of it. Then you go through another menu-based program where you say, okay, if it's slow shipping, the final price is going to be times 1. If it's medium, times 1.1. If it's fast, then times 1.5. And then finally, just give me all I really need to know is the final total. Okay, any questions on that? So I'm going to give you 1 week. I think for most people that should be okay. Reason being is because for most people in here, this is your second or third programming class. And then just send me get started on it right away. That way, if I need to add additional resources, like I don't know, like maybe an additional lecture video, or maybe form an online study group to help people out, or something like that. I need to know that like right away rather than the day it's due, okay? And don't forget, these are always due at the end of the day. So if you're like almost finished and you just had a quick question in class, you can always ask that, and then, still have a few hours to turn that in. Is anybody confused at all how the program is, or the problem is stated? Does it make sense to everyone? Okay, so keep in your head when you're writing this, always keep the big picture, is that there's two parts. The base price, which is based on the weight, and then the secondary part, which is based on the shipping speed. Okay, so enough of that. So assignment number 3 is just based off of that. We're going to do some new stuff. Don't get confused and think that you're going to need lists and loops and all kinds of other stuff. Really, for that assignment, all you essentially need is just this example. Okay, so let's open up a new REPL here. What's that? Oh, was it? Huh. Okay, so everything we've dealt with so far was dealing with one number at a time, one variable at a time. Even with our if statements, we were checking for one thing at a time. In practice, it's much more convenient, or sometimes even essential, to deal with collections of things. And you've probably already dealt with this with previous. Does everyone remember arrays from your other classes? And so in Python, we don't specifically have arrays. We have these things called lists. Now, lists are very similar to arrays, but there's some mechanics underneath that make them a little bit different. But in your head, you can think lists, okay, these things are very similar to arrays. Sometimes, actually, I'll even catch myself calling them arrays. The difference between an array and a list is, if you remember from arrays, is that I would have to create a fixed size array. I would have to say ahead of time, I want this to be 5 elements or 10 elements or whatever. With a list, we actually don't have, it'll expand as much as we need it to. And most other languages have some sort of equivalent. Like in C++, the equivalent would be like something like a vector, or in Java, they have array list. So just keep that in mind, is that they're kind of similar, but they're a little bit different. So let's do this. Let's say, for example, I wanted to, so let's walk through this. So if I had a class of 3 students, which is not really, that doesn't really happen, but let's just pretend I did. And let's say, for example, I had student 1, and their final grade for the class was a 92.3. Student 2. So I have these 3 individual students. What would I do to find their grade average?
Add them all up and divide it by 3.
Exactly. So what I could do is I could say that the average is student 1 plus student 2 plus student 3 divided by 3. And let's put some parentheses just so it's a little bit more clear what's going on here. So we're taking all these, adding them up, and then dividing by 3. And then I could print the average. I don't know for certain, but I'm guessing that this is probably another instance of floating point arithmetic showing up. What if I had 30 students, or 50 students, or 100 students, or 200 students?
It's not feasible to put them all average like that.
Yeah, it's not really practical anymore. So what do we have to do instead? We have to be able to address, rather than one student at a time, we have to be able to address the idea of a class of students, an entire room full or group of students. And how do we do that? Using a collection. In this case, we're going to use a list. So how do we convert this to a list? Well, so what I want to do is a couple ways to handle this. I'll say, rather than having student 1, student 2, and student 3, I'll have a list of students, and then we use the square brackets, and then I'm going to say, okay, that this one's 92.3. This one's 87.9. This one's 94.0. That means I can actually just get rid of these now. I'm going to comment out this code just for a second. We'll bring it back in a minute. Now I can print students, and it'll print out the list. Notice that's a list because it has this, the square brackets. But that doesn't completely help me, because what if I wanted to still address one student at a time, say in some sort of like a loop or something like that? How do we do that? Well, just like with arrays in other languages, what I can do is I can say students and then the square brackets and then some number, and it's 0 indexed. So if I wanted to find the 0th student, which should print 92.3. Now, if I try to print a student number that doesn't exist, I should get an out-of-bounds exception. We'll explain exceptions later on in the course. Yeah, index out of range. So now we actually, you can't really think of it as a direct equivalent of arrays, because in Python, because it's meant to be like a higher level language and it's supposed to give us some nice things for free, we can do some interesting things. So let's do this. I'm not going to really explain too much here, but everyone remembers for loops and while loops, correct? It's that you loop over something over and over again. So I'm going to write a piece of code here. I'm going to say for student in students. And then remember, so because this is a block of code, I have the colon here. I'm going to say print student. So we can actually, this is one way to loop over that list. And for the most part, this is very often the way you do that, because this tends to be much more convenient. You don't have to use that square bracket notation, which can get a little bit difficult to read. Usually you just want to deal with one student at a time. So it has this thing called a generator. And as you're looping over the list students, it gives you back one student at a time. So this is the existing list, students, and it's saying, okay, each time populate this variable called student, and then when I'm inside of this block, I get to use that student. And that's why it printed 92.3, 87.9, and 94.0. So that's nice. If I want to get the value of each student one at a time, I can do that. The other thing that's nice here is that if I wanted to add them all up, what I can do is I can say, okay, start with 0. So I'm going to say that the total is 0. We'll say 0.0 because they're floats. And then each time through, I can say that the total is equal to the old total plus the value of that student. So the first time through, it would say 0 plus 92.3. The next time through, it would be 92.3 plus 87.9, which would get some number. And the last time through would be that number plus 94. So hopefully you can see what would happen is that it would essentially accumulate all the values. So at the end, we should have like a grand total. We're close, but the problem didn't say to get the total. What did the problem say to do? Is that we wanted the average. So how do we find the average? Well, before we added all of them up, which we've already done. We've gotten the total, but then we have to divide by some number. So we could say that the average is equal to the total divided by 3. Now, what if we wanted to add a new student? We could do students.append, and let's say this student got a 78.9. And just to see that it's printing all of them, what I'll do is I'll say, okay, print student. Notice that we see the new score in there. That's 78.9. But that average doesn't seem right. How can you have all of the values are less? And so you start searching through, and what do you see here?
Oh,
I'm dividing by 3, but how many students do I actually have?
4.
You generally want to avoid hard-coding numbers like this. You want to sort of dynamically know how many students there are. So we could track this in a separate variable, but there's actually a function that'll return that for us. There's a function called len, short for length, and that'll return the number of students. And so no matter how many students we add, this always knows the correct number of students. So this will return some number, in this case 4, so it'll do the total divided by 4. And if we added another student, it would divide it by 5. And then now that looks to me to be the correct number. And I'm just going to, I don't want to delete that. You might want to use that for later, but all we really care about is the average. So we'll get into loops and these very lists, and we have some other things called sets and dictionaries, and I think that's what we mostly deal with in this class. We'll get into those more as the class goes on, and this is really where it starts to diverge from like a COP2030 class. This is probably the last class that we'll share any sort of assignments or any sort of material, and then from there on we get more complex data structures that we don't really cover in that initial class. Okay, so no assignment on this week. Most likely I'll post something next week related to lists and dictionaries and stuff like that. But any question on just this basic problem here? Everyone's good? Okay, so let's do this. We can, we have a little bit of time, not a whole lot, but you can use it to get started on the assignment. And that way if you have any questions, you can ask me. And then if you're in REPL, you could just save, and then when you get home, you can restart it. Okay. So any questions while I'm recording on anything?